Question is, how many positive integral divisors of n equal to 2 raised to 6 into 3 raised to 5 into 5 raised to 4 are there? Now, any integral divisor of 2 raised to 6 into 3 raised to 5 into 5 raised to 4 is of the form 2 raised to something into 3 raised to something into 5 raised to something. Now, how do I write this mathematically? I write that divisor D as 2 raised to A into 3 raised to B into 5 raised to C. What we need to see is that what all possible values for A, B, C are there. Now, I say A can take integer values from 0 to 6, B can take integer values from 0 to 5, and C can take integer values from 0 to 4. Now, your question could be that why am I including these zeros in these sets for possible values of A, B, and C? Now, see, there can be a divisor which does not involve any power of 2, or it may be it doesn't involve any power of 3, or it may be that it doesn't involve any power of 5. So we need to include these zeros. What we observe from here then, that A can take possibly one value from these 7 values, B can take one value from these 6 values, integer values, and C can take one value from these 5 values. So basically, finding a divisor, this would be complete when we fix values for A, B, and C. So this activity is actually done in 3 parts. One, that you decide value for A, 2, you decide value for B, and 3, you decide value for C. So we can use now multiplication principle, and multiplication principle will tell me that how many divisors are there. Now multiplication principle tells that I need to multiply this 7 into 6 into 5. From where I'm getting these 7, 6, 5? These are the possible ways in which A can be selected, B can be selected, and C can be selected respectively. So total number of divisors, which is our requirement, is nothing but 210. That is the final answer.